printing with a 0.6 nozzle on the Bambu Lab H2C. Let's go. Quick disclaimer, this video is not sponsored. Bambu Lab didn't send me this printer. I bought the H2C printer with my own money. Hi everyone, quick video today with some further tests on the Bambu Lab H2C 3D printer. The prints shown here are mostly printed with a 0.6mm nozzle, and overall the print quality is genuinely really good. But then I spotted a proper in-your-face seam line on a customer-facing print. I immediately thought, right, I can fix that. Also seen on this white PLA filament print. So I went hunting on Bambu Lab MakerWorld for seam test files and found a simple cylinder pair project. One of the cylinders is set up to print with scarf joint, and the other is set up with a regular seam. In this first print, the scarf joint cylinder is white, and the regular seam cylinder is blue. In real life, the scarf joint looked great, but on camera I couldn't capture it properly. The lighting was too bright, and I couldn't clearly show on camera where the seam actually was. I reprinted it, flipping the cylinder's colors so it's easier to see on camera. The scarf joint cylinder is blue this time. On the blue cylinder, you can just about see where it starts and ends. Two faint vertical lines here and here. But on the white cylinder, with no scarf joint applied, the seam is obvious. My conclusion? The scarf joint algorithm is seriously good. On this model, it hides the seam so well that my bigger problem became filming it. And I don't think this is some H2C only magic trick either. If your slicer and motion system can do a similar scarf variable seam approach, I'd expect very similar results on other printers too. The cylinder test is great, but the real question is, does this work on a real part you'd actually use or sell? So I tried to take what I learned and apply it to the part I showed earlier, the lampshade. As seen earlier in the video, this is the very first print, and this is the seam I set out to fix. This first attempt had a couple of issues, but let's start with the scarf joint itself. The results are very disappointing. While it could be due to the geometry of the lampshade, it's disappointing nonetheless. The overlap region or transition zone didn't come out well at all. Another glaring issue is these defects up at the top. On the first print, I used Arachne as the wall generator, but for this run, I used Classic, so I assumed that could be a factor. I switched the wall generator back to Arachne, left the scarf joint approach in place, and printed again. Result? The transition zone problem remained unsolved. I tried a few tweaks, but nothing I changed improved the transition zone. And in the end, I rolled everything back and stuck with the default settings, because on this lampshade geometry, the defaults gave me the best overall outcome. While editing this video, I had a thought. What's the wall thickness supposed to be in the model? So I measured it, and it turns out it's 0.8 millimeters. The profile wall thickness, however, defaults to 0.62 millimeters when using a 0.6 millimeter nozzle. The slicer used a single perimeter, and that can change how the slicer generates the wall and consequently the scarf joint. An off-camera measurement shows this is precisely the wall thickness of the printed shade, which means the printed wall can end up thinner than the source model. So the issue could actually be due to an interaction between nozzle width, model wall thickness, and part geometry. Next steps. I've placed an order for a 0.8 millimeter nozzle, and I'll also reprint using a 0.4 millimeter nozzle. That should give a clean comparison of how nozzle width changes the seam and overlap behavior. I tried printing another part in Vase mode, and it failed. The printer's spaghetti detection picked it up quickly and stopped the print. I didn't stop there. I tried again with a different filament color. That also failed, and again spaghetti detection caught it almost immediately. You're looking at real-time footage of the Vase mode failure here. To understand what was going on, I printed the exact same file in normal mode. It printed sort of okay-ish, but as you can see here, some extrusion didn't adhere correctly. These displaced filaments shown here are not stringing, but entire layers, given that it is a single wall print. This is definitely a source of failure, because we're basically missing a whole layer in the affected sections, which makes the part unusable. These Vase mode prints probably failed because of the geometry of the part I tried to print, and the fact that the printed walls are thinner than designed wall. So rather than trying to extrude a 0.8mm wall from a 0.6mm nozzle, I've decided to buy a 0.8mm nozzle for these prints. Next, I'll run further tests with the 0.8mm nozzle, and I'll also compare it against a 0.4mm nozzle on the same geometry. I picked a different geometry and tried it in Vase mode, and yes, as expected, it worked on this design. If you look closely though, you can see gaps in the print, visible as the printer moves from the 12 o'clock to 9 o'clock area. Here's the outcome. The main body is outstanding, there are no visible seam marks, but off camera, the bottom piece came off. Just to be clear, all these prints were attempted before I drew the conclusion that this could be an issue with the wall thickness mismatch. Alright, let's assemble and test the lampshades. I've already fitted the E14 lamp holder and the bulb. All I need to do now is push it through and lock it into place. Quick light test. It looks great, but it's genuinely hard to show the true intensity on camera. I also tested the white lampshade, and I've tested a few more lampshades in different colors and styles. I'll show them on screen here. Thanks so much for your support, for the comments, likes, and all the feedback. Quick note, these shades are not my design, and I'm not allowed to share the files. They're Leah's shades from MakerWorld. Next, I'll show the results with the 0.8mm nozzle and a bunch more projects in upcoming videos. Take care, and I'll catch you in the next one.